Do we find the components first?
Do you have to? Look at our formula. All right, folks. If it's taking you long in this, you're doing it the wrong way, so let's do it. Guys, there's a lot of chatter. Some of you feel like you've got this. You probably don't. You're in for a surprise. Torque equals F cross R. So I use my same formula. The magnitude of the first, magnitude of force is therefore 34, right? Magnitude of the second, 0.1. Sine the angle between them. What's the angle between 0 and 60 degrees? 60 degrees. Put that in my calculator. 34 times 0.1 times sine of 60 degrees. And I get 2.94. Everyone with me?
I'm just wondering, why do you sine the angle on the
Because you actually want the perpendicular part, which is, if you look at the components, perpendicular is opposite.
So it's just cheating to find the perpendicular, not cheating, but
What we're doing.
not using the
Right. By the way, we'll do it the component way in just a moment. Fear not. All right. This is the wrong answer. So I hope those people are chattering are now with me. Because it's incomplete. Cross products always have a direction. They always have a direction. I need a direction, and the direction is most disturbing of all. Welcome to advanced math classes. So I have here, I'm going to draw a glorified wrench.
nice square.
I've got a nice strange bolt on the end, specialized bolt. And they've got a wrench here, little adjustable thing over here. All right, good. Okay, so I've got a wrench. I've got it attached to a nut. I'm getting ready to push the wrench. Is there a difference between going, first, a difference between going this way or this way?
Yes.
What's the difference? Lefty loosey, righty tighty. All right. We need that as an answer because as we're talking about torque, it matters. Now, to bring up a point, why is this a cross product? We're talking about torque, and this is ever so briefly. Don't fall us to deep depth, just the surface area. If I take the wrench and I push it this way, is the wrench going to turn? No. If I go perpendicular to the radius, so the radius is this way, and the force is this way, am I going to turn the nut? Yes. And so force cross radius, now if I go at an angle, I got less strength. So I need to get straight on the strongest. That's why cross product, and that's what we're talking about. Now, that said, that's a bunch of stuff that has to do with math, but I want to explain the math a little bit. If I go this way, I need it to give me an answer. What does it do? It pulls the nut out, correct? If I go this way, it's going to put the nut in. So I want you to do the following thing. I want you to take your right hand. Here's my F vector. Here's my R vector. Agreed? Here's F. Here's R. I'm going to karate chop the F. So on your paper, I want you right now, I want you to sketch this really quickly, and then I want you to karate chop the F. Now, do my fingers naturally curl towards the R?
Yes.
They do. No problem there at all. Now I want you to stick out your thumb. Which way does the nut come? Out. Out of the page. So the answer would be out of the page. What if I was going this way? I karate chop it this way. Do my fingers naturally curl towards the R? No. So I need to flip over my hand and karate chop it the other way. Bang. Curl my fingers towards the R. Which way does the nut go? Stick out your thumb.
In the paper.
In the paper. So if I were to push the wrench this way, it's in. If I push the wrench this way, it's out way. We call this the right-hand rule. It is the mathematical way to do lefty-loosey, righty-tighty when things get really ugly. Okay? So, you karate chop the first one. We're going to practice more later. Don't worry about that. We'll get some. But I want to show it to you at least once before we move on and start talking about what you do with components. So if you go right hand, you karate chop it. You curl your fingers. You stick out your thumb. That's how you do the right hand rule. Notice it only works for your right hand. Left hand gives you the opposite answers. Okay, use the right hand. Ah! Karate chop it this way. Doesn't work. Flip it over. Karate chop this way. Oops, that doesn't work either. I got to point my fingers the right way. Oh, karate chop it this way. Curl my fingers. Out comes the thumb. And when I go this way, I'm tightening the bolt, pushing it in. All right. Now that's not the end of it all. Because what if I want to do the same thing with components? I have a different example down there. I have two vectors down there for you. One of them is, one of the vectors is 0, 4, 1. The other is 0, 1, 3. With me so far? Okay. So then I would set this, so I need a way so that my I-hats, what I'm doing is I multiply this times this, and then I'm going to multiply this times this one here, right? And then I'm going to, for my j-hats, I have to multiply this times this, and this times this one. Right? Because when we talk about a cross product, and then we multiply that which is perpendicular, right? So this is my, if this is my I-hat, for my I-hat I would need to multiply the j of this one times the k of this one, and the j of this one with the k of this one, wouldn't I?
So wait,
That would be really, yes?
the third term in the 3 is k-hat?
K-hat, right? I, j, k. Okay? So if I multiply this one times this one and this one times that, this gets really confusing, right? I have to be really careful how I do that. Fortunately, we recently came up with a way to start doing cross products. We actually ran across it. Hopefully, if you did your homework, you're right now already anticipating what I'm about to say. I, j, k, 0, 4, 1, 0, 1, 3. And then I'm going to add 2 more rows. I hat 0, 0, j hat 4, 1. Now I'm going to do what? I hat. Don't give up, man. We got 15 more minutes, and you're taking a quiz next time. And some of you are going to be here Friday. This is the last time you're going to see a cross product until you're like surprise taking test. Yes?
I have a question. Why is it that it ends in the answer and only an I-hat?
Let me do the problem first. Okay, so I'm going to go like this, and I'm going to go 4, 1, 1, 3. It's a good question. We're going to get to it. Next one will be j hat. 1, 0, 3, 0 plus k hat. 0, 4, 0, 1. If you did your homework, you should be able to do at least that fast. Now I'm going to go do my magic, right? I'm going to take this times this minus this times this. Agreed? This times this minus this times this. So I'm going to go I hat is 12 minus 1 plus j hat, which is 0 minus 0.
So this is basically Uber 4.
Plus k hat is 0 minus 0. And I end up with 11 I hat plus 0 j hat plus 0 k hat. Now the question he asked, I just answered. Most of you thought I just answered it, but I didn't answer it yet. Follow this if you can. In the I hat direction, this vector goes how far? 0. How far does this one go? So when I want to figure out what j is, I'd multiply how far it goes in the I times how far it goes in the k. How far it goes in the I versus how many times it goes in the k. Since it goes nowhere in the I, there can be no j, right? There can be no component in that direction because there's nothing in the I to multiply by. There's nothing perpendicular to that. So it has to drop out. So that's the long answer. Now, a better way to answer that same question is to go back to the wrench problem. And I'm only going to do this briefly, but I want you to follow, okay? Make sense so far? Okay, so this is the way we're going to do it. This is the way we do the problem. The reason why I do it this way is because it's organized in such a way that our heads don't explode, trying to do the I's and J's with the cross product in our head. It's important you do it in order, for reasons I'll get to in a moment. So far we got, everybody can do this for homework? Yeah, okay, so here we go. Remember the one we did. What was the fourth one? It was, give me the components quick. It was not the components, but the original, the wrench.
It was 34 at 60.
34 at 60, cross 0.1 at 0. Okay, so I'm going to break these into components. Agreed? You guys remember how to do that? So it's 34 sine, 34 cosine. So 34 cosine of 60, I get 17, comma, 34 sine of 60, and I get 29.445. Agreed? Now I'm going to do this one. This one I've got 0.1 cosine of 0, I get 0.1. 0.1 sine of 0, I get 0. Well, that makes sense because it's all in this direction, right? It's going to be all in that direction. Everybody agree with me so far? Sort of, at least know what I'm doing. Know what I'm doing? Know what I'm doing? Okay. So now I'm going to do the cross product on it. Now, I would never do it this way. I'd do it the way we just did it, right? I do this times this, right-hand rule. But let's see if the cross product works and how it works, okay? So I'm going to go ahead and go I, J, K. I still have to have a K, oddly enough. I'm going to put in 17, 29.445. What's K going to be? 0. I had nothing in that direction when I started. I didn't push it outwards. I'm not taking the wrench and shoving it this way, out of the board or in the board. I'm shoving it this way. Okay, what about this one? 0.1, 0, 0, right? Be 0 right here. So now I'm going to add the first two rows. And 0. So far, so good? Now, what am I going to do? I hat is going to be this times this minus this times this. So that's going to be 0 minus 0. So I hat's going to fall off. Plus J hat is going to multiply this times this minus this times this. No J hat, man. Plus K hat. This times this minus 2.94 K hat. I get 0 J hat, I hat, plus 0 J hat, minus 2.94 K hat. What was the answer we got using the sign? 2.94 would have been in or out. We didn't actually check. I showed you both cases. F is this way, R is this way. 60 degrees. Start with your F, curl your fingers. Does that work? Nope. Flip it over, probably drop it the other way. Curl your fingers. Into the board. So the correct answer would have been into the board. Into the board. So since it's into the board, what's this minus sign mean? In the K direction. Well, this is I, this is J. Which way is K? K is out of the board, so the negative means into the board. Give you the same answer. Now, what did it do to do that? It took this direction, which was nothing. It said these two, this times this, because those are perpendicular to each other, and it got 0 because there's nothing perpendicular that way. They took this one times this one, which are perpendicular to each other, and spit out an answer. The minus sign controls the right-hand rule. And that's why it works. Yes, sir?
The answer is actually giving us just the torque, not actually a distance that it moved in or out.
Right, nor does it, well, it tells us the direction it's torquing it in to the board. Minus means in.
Yes.
If it was positive, it would mean out.
But on the
Yes.
question over here where we
Yes.
got the same answer, I didn't get a negative.
Well, you didn't because you didn't use the right-hand rule. But the right-hand rule you have to use, right? Because I said you had to use it. So if I karate chop, I drew it.
So you're going towards your angle.
Hold on. Get the first part. Did I draw it?
Yeah.
Everybody else listen, by the way, because I'm going to answer this question another 6